Hey, welcome back to the lecture. So in the previous lecture, we came to know that we have a couple of clock sources for the microcontroller, right? First one is crystal oscillator, which is actually connected external to the microcontroller. And inside the microcontroller, there is something called RC oscillator. So where RC stands for resistive and capacitive circuit. And the third one is PLL. So PLL stands for phase lock loop. So PLL and RC oscillators are built into the microcontroller. In this lecture, we are going to understand the whole clocking engine of the microcontroller. And the reference microcontroller I'll be considering for this lecture is STM32F407 microcontroller, which is there on the discovery board. To understand the clock tree, there are a couple of options. So the first one is, the best place is, of course, you have to open the reference manual of your microcontroller. So if you are using some other microcontroller, then don't worry at all. So just follow these steps in order to find out the clock tree. Basically, you have to go to the RCC block or RCC peripheral of the microcontroller. So here it is, a reset and clock control for STM32F45 or 07, right? So I would be using this, and here just expand this and click on clocks. And after that, so just browse through this document. So you will encounter a big diagram here, which is a clock tree. So this is a clocking engine of the microcontroller. So this diagram looks intimidating, but don't worry, this is a very simple diagram to understand the whole clocking engine of the microcontroller. So now to understand this diagram better, so what I'm going to do is I'm going to use the IDE. So now let's open our STM32Cube IDE and let's create a project. Let's open the workspace. So now let me create a project. So you can create file, new STM32 project, and here let's go to the board selector and type in your board name. I'll be using mine. And after that, let's click next, and here let me give one name. Let me give the name clock or something. So since we are understanding about clocks, so here you select STM32Cube. Why? Because if you create this project as a STM32Cube project, then we can get one nice GUI where we can do the clock configuration. And after that, click next, and after that, finish. Then what you should do is here click no, that's okay. And here you click, do you want to open the perspective? Yes, basically it opens a CubeMX perspective. Let's click yes here, and after that let's wait for some time. So here's the thing, guys, it is trying to download this cube firmware. That is, it is trying to download whole HAL layer for that microcontroller. So click cancel. We don't want to install that. It is okay. It is saying code generation could not be done. That's okay. In this course, we are not using code generation. Click OK. That's it. And here it is. You get this diagram as a nice GUI here. I use this to explain students because here I can change various things. Because it's a GUI, I have various options to change various things. So I said we have three clock sources, so crystal oscillator, RC and PLL. And in this diagram, you can identify those sources as HSI, HSE and PLL clock. So now what is HSI? So HSI stands for high speed internal. So that's why the RC oscillator is called as HSI, high speed internal. So and HSE stands for high speed external. So in our case, crystal oscillator of 8 megahertz is connected external to the microcontroller, right? So that's why our crystal oscillator is called HSE. In our board, the HSE oscillator is of 8 megahertz. This information you have to obtain from the user manual of the board. Remember that, not from the microcontroller, right? So this depends upon the board designers, not microcontroller designers. But microcontroller has some guidelines, like the value should be within some limits. Here you can see that this microcontroller says that the HSE must be in between 4 to 26 megahertz. So in our discovery board, it is of 8 megahertz, which surely falls in this range, isn't it? And you can also see that this HSE is connected all the way to these microcontroller pins. Right, there actually you have to connect the crystal. So now let's go to the RCC section once again, and let's click on clock and click on HSE clock. Here it is. So look at this diagram. So this is how you connect crystal or ceramic resonators. So these are the microcontroller pins. So in between you actually connect the crystal oscillator or ceramic oscillator. So if you want to know the exact value of this, as I said, you have to refer to the reference manual of the board, so which we'll see later. There is also one more way of providing HSE to the microcontroller, that is by using external clock. In this case, you need not to connect the crystal oscillator. So you arrange for some external clock using external sources. So like another microcontroller or another circuit or another part of the PCB or something like that. So you actually derive the clock from some other circuit of the board and then use that as HSE to the microcontroller. So that is this mode, external clock mode. So this is crystal mode. So in both ways you can give the HSE to the microcontroller, that is high speed external clock. Now here's the thing, if you are using discovery board, then you need not to worry about this. Why? Because all discovery boards come with crystal oscillator installed on the board. But in the case of Nucleo, you cannot use this mode because Nucleo boards don't come with onboard crystal oscillator. So in that case, you have to use this mode, external clock mode, where we actually pull the clock from the ST-Link circuitry. So there is a ST-Link circuitry, right? Both on discovery board and Nucleo board. So ST-Link circuitry has its own microcontroller. Now from there, we pull the 8 MHz clock and we use that as HSE. So this configuration we use in Nucleo boards. Now to know more about these crystal oscillators and external clock thing, you have to refer to the user manual of the board. So I am taking you to the user manual of the board. So here it is. And here, let's go to the section clock. Now here you can see that there are 3 ways from which you can give the external clock. So I'm talking about the HSE. The first one is MCO, that is microcontroller output from ST-Link. That means you derive the clock from the ST-Link circuitry and then give that clock as HSE to the main microcontroller. And after that, or use the oscillator on board from X2 crystal. So if you are using discovery board, then there is an oscillator on board. Let's check the schematic to understand this connection, X2 crystal connection. Now I'm taking you to the schematic of the discovery board. So this is a schematic, and here let's search for the main microcontroller. Let's browse through this document, and here it is. This is a main microcontroller, STM32F4VGT6. And now let's search for X2. So here it is, 8 MHz of crystal is connected between the pins PH0 and PH1. Right. And you also see one more crystal here, X3. That is actually 32 kilohertz crystal. That is not megahertz. So that is kilohertz. That is used for real-time clock peripheral of the microcontroller. And you can see that that is not fitted. So that is not available on the board. So if you want to connect that crystal, you can connect something like this. So that's what the schematic is saying. So we come to know that our HSE is 8 MHz for the discovery board. Let's check the schematic of Nucleo just for your information. But before that, let's read the user manual of the Nucleo board. So I'm in the user manual of STM32 Nucleo 64 boards, and it must be applicable to all these boards. So this is, I'm just showing for your information. So because there are a lot of students who are using Nucleo boards because it's a low cost board. So here also you can go to the oscillator section, and here it is. So HSE is derived from microcontroller output from ST-Link. This is a default configuration for HSE in Nucleo board. So, or you can also use HSE oscillator on board, but this is not provided. So let's open the schematic. If you open the schematic of Nucleo board, here you can see that. So you have to search for X3 right here. So it says that not applicable, not applicable, not applicable. All these components are not fitted. So that's why it is showing not applicable. But if you want to connect X3 or 8 MHz crystal, then connect here as shown in this diagram. So here you can see that instead of using crystal, they actually derived the clock from MCO. this signal comes from the ST link. This is actually closed. So in future, if you think about installing your own crystal, then what you have to do is you have to just desolder this. You have to open this switch, that's it, if you have any plan to connect the external crystal. But don't do anything to the board. By default, it can pull the HSE from the MCO of ST-Link. So summary of HSE. So HSE can be provided to the microcontroller via a crystal or external source, that is from another circuit or from another microcontroller. So on the STM32 Discovery board, HSE is 8 MHz provided by the onboard crystal. On Nucleo board, HSE is of 8 MHz pulled from the ST-Link circuitry. And please note, do not do any soldering or desoldering on your board for this course. You need not to make any changes unless you have any special requirements. So this course doesn't demand you to do any soldering or desoldering on the board. So with that note, I would like to end this lecture, and I will see you in the next lecture.